So I believe on Friday we'd gotten through part A on this question. Is that correct? Yep. Okay. Can you guys help me fill in my page real quick so that it is caught up to where yours is? How many planes appear in the figure? 6. Did we name those 6 planes? Yes. We called one of them plane P. Okay. What else? Plane GAC. Okay. What else did we have? Plane FGA. FGA. What else? EFA. EFA. Got 2 more to go. Give me another one. ABD. And then the 6th one. What was the 6th plane? ADE. Wonderful. All right. Name 4 points that are collinear. What does collinear mean again? What does collinear mean? Yeah, all together on a line. So I want 4 points that are all together on the same line. There's only one spot up here in this picture where there are 4 points that are all on the same line together. What are those 4 points? H, I, C, and F, yes. Beautiful. Name the intersection of plane GAC and plane P. Well, we already know that plane P is this plane down here. Plane GAC, here's G, here's A, here's C. So this guy right here is plane GAC. Does the bottom, plane P, my purple plane, and GAC touch each other anywhere? Yeah. Can you name a point where they touch each other? C. Anywhere else? G. C and G and all of the points that are represented by this little line segment, this dashed line in between. And so I'm going to put the line with arrows over the top of them because it's not just those 2 dots. It's not like this plane comes down and only touches in these 2 points. It touches in all the space that's across there as well. Wonderful. And then D. At what point do line JI and DC intersect? So let's go find those. JI is this line right here. And DC is this right here. So this one might be a little bit easier for me to describe with my folder. My folder represents what? A point, line, or plane? A plane. This line right here, DC, is like if I drew a Sharpie line on my folder right here, okay? This line, JI, is like if I took my pencil and I stabbed it through my folder. So it's going through the folder, and this is a Sharpie line that's on the folder. Where do those 2 touch each other? They don't. Good answer. They do not intersect. Very nicely done. All right, let's flip over to page 4 now. Refer to the figure. Name 3 points that are collinear. There's only one spot in the picture where we have 3 points all in a line together. What are those 3 points? B, D, and A. Nicely done. Looking at the picture below it, once again, I want 3 points that are collinear, and once again, that only happens at one spot in the picture. What are the 3 points in this bottom picture that are all collinear? Q, S, and T, yes. Q, S, and T. How many planes appear in this figure? We don't need to name them all. We're just going to say how many. This shape right here is a prism. What shape is the top of the prism? A triangle. Is the triangle flat? Yes, so that would count as a plane because it is a flat space. So that's one plane, the very top of this prism. How many sides does a triangle have? 3. So how many faces are there around the top of the triangle? 3. So that's 3 more flat spaces, 3 more planes. So now we're at a total of how many? 4. Are there any other planes in the figure? Yes, we've got this bottom for a total of how many planes? 5 planes. Nice job. All right. Name the intersection of plane RST and plane A. Plane A is this right here. And plane RST, well, here's R, here's S, and here's T. So this face is plane RST. Does RST touch plane A anywhere? Where? T and U. So T, U, with a dash and arrows over the top. Nicely done. Very nicely done. All right. Let's get some things written down in your own words underneath number 9. What does it mean if points are collinear? Yes. The points are all in a line together. The points all lie on the same line. What does it mean for them to be coplanar? All in the same plane, yes. The points all lie in the same plane. If points are collinear, if points all lie on the same line together, they have to be coplanar. They all have to be on the same flat space together. Think about a piece of paper. If I draw a line on a piece of paper and some dots on that line, they all have to be on the same flat space as that piece of paper. But if I have points that are coplanar, they're all on the same piece of paper, do they have to all be in a line together? No. So if they're collinear, they have to be coplanar. But if they're coplanar, it doesn't mean that they have to be collinear. All right, let's look at this picture of a box here and see if we can answer a couple yes-no questions and then identify some pieces. Are the points R, S, and W collinear? No. They do not all lie on one straight line together. All right, next question. Are the points Q, R, S, and W coplanar? Are they all in the same flat space together at the same time? No. What about if I were to take W away? Would those be coplanar? Yes. What about if I were to take Q away? Yes. If I take Q away, R, S, and W are all on the same plane together. Nice job. Are the points T, U, and P coplanar? Yes. T is here, U is here, P is here, so plane TUP is the left-hand side of this box. All right. Name the intersection of plane TWV. Here's T, Here's W, here's V. So plane TWV is the bottom of the box. And plane QRV. Q is here, R is here, V is down here. So the back of the box and the bottom of the box touch each other where? U and V. And what else do I need other than those two letters to make this right? Yep, I need the line like this. Has to have the arrows. We need the dash with the arrows there. Nice work. All right, part E. Name the intersection of plane PQT, PQT, so that's the left side of the box, and plane UQV, UQV, that's the back of the box. Where do those two meet? QU, yes. QU. And what do I still need? Yep, I need the line with the arrows over the top of it. Super important. And we're actually going to start to talk about some differences in notation a little bit later today. So whether it has the dash with arrows or not is really important. Name the intersection of line PT. Line PT is this one right here. And line SP, this one right here. Where do those meet? At P. So we're going to call this point P. Nicely done. Very nicely done. All right. Down at the bottom of the page and at the top of the next page, we have some real-world scenarios where we're going to identify whether this is best modeled by a point, line, or plane. We did this on Friday. We looked at several objects that were all laid out on a desk together, and we wanted to know whether those were best modeling a point, a line, or a plane. So here I have an airplane. Specifically, I have a biplane. It has two sets of wings. There are struts that connect those wings together. A strut is kind of like a sturdy stick that's going to touch the top and the bottom wing to hold them a certain distance apart. And then they have these flying wires that run in between the wings that also offer some stability. I want you to think about not the way it's drawn in the picture, but if you were actually standing in front of it in real life. The wings on this plane, would those model points, lines, or planes? The wings. Plane, yes. Because remember, the wing would be a flat surface. It has length and width to it. It has length and width. The intersection of a strut and a wing. So if a wing is modeling a plane like this, and I said a strut is kind of like a stick that keeps the wings a certain distance apart, what would you call the place where the strut and the wing are touching each other, where they're meeting? Right here, would that be a point, a line, or a plane? A point, yes. What about where the two flying wires are crossing each other? What would that be? I think each of the wires would be a line, but I want to look at just where they're crossing each other. Intersection. What would we call that intersection? A point, a line, or a plane? A point, yes. All right, let's flip the page. Now we're going to look at a game of golf. The ball in a golf game would best represent a point, a line, or a plane? A point. The green, which when we're talking about golf, the green is where you're putting. It's the ground that you're putting on. Would the ground best model a point, a line, or a plane? A plane. What about the flag stick? A line. The stick itself is going to represent a line. Now the hole where the ball is going to go in would best represent what? A point. Very good. All right. That, in your notes, everything at this point and earlier in the notes is what you're going to need to do the homework that's due tomorrow. If you need another copy of the homework, I have more copies over here. Whenever you are out, if you miss a day and you want to know whether or not there were any papers passed out on the day you were absent, you can always find those or any extra copies in this red organizer over here. The most recent stuff will always be towards the bottom with the oldest stuff up at the top. So when you've been absent, you want to come over here, you want to start at the bottom and work your way up until you're like, nope, I've got that paper. You want to grab everything below that point. All right? So homework, when you guys come in tomorrow, we will grade that first thing. I'll take attendance, and then I'll put up the answer key. Remember, I grade homework based on your completion of the work, and then based on the corrections that you make once I put the answer key up. After we have done that, then you guys will turn the homework in, and we'll continue on with notes. But we are going to start the next section in your notes right now. This will go with the next homework assignment. So what we've already completed, you're going to use for the homework that's due tomorrow. This next bit goes with the homework that you will receive tomorrow. All right, so number 1 on here says draw 4 points in the order K, L, M, N on the line. So I'm going to put K right here, and then L, and then M, and N. Are points K, L, M, and N collinear? Yes. Be careful and think about it for a second. Are points K, L, M, and N coplanar? Are they all drawn on the same flat surface together? Yes, they're all drawn on the same piece of paper. So yes, they would be coplanar. If they are collinear, they're automatically coplanar. If they're coplanar, they don't all have to be in a line. But if they're all collinear, they have to be coplanar. Name 3 different ways to name the lines. So if I want them to be different, they need to be distinct. How many letters, how many points do we use to name a line? For a line? 2 for a line. Which ones get 3? Planes. Planes get 3 letters. Lines get 2 letters. Only 2 letters. Only ever 2 letters. No more than that for lines. So I could name this line KL with a dash and the arrows over the top. If I want something to be distinct, which I just realized I misspelled, there we go. There has to be at least 1 letter different. Can you guys give me another distinct name for this line up here? What'd you say? MN, yes. MN would work. Can somebody give me 1 more? LM. That would absolutely work. Could I call this KN? Yes. I'm going to go ahead and write that one down since we said it. KN. Can somebody give me 1 more? I know it only asked for 3. KM. Yep, we could do KM. Absolutely. As long as it is 2 points on that line, it will work. If we put 1 more point on the line, if I put a point over here, would that make my line longer? No, why not? What do we know about the ends of lines? They go on forever, yes. So we're going to say no. Lines extend forever in both directions. All right. How many distinct or different line segments are on the line. So do you guys remember before when we've talked about distinct names for lines? If I just switch the letters around, is that an okay name? Is it a distinct name? Same thing with line segments. I can choose the same two letters and flip them around. That's an okay name, but it would not be a different name. When we're talking about line segments, we're talking about entirely different objects. But if I just switch the letters around, it is not distinct. It is not different. All right, so I'm going to walk you through how I find all of the distinct line segments on something like this. And this is not the only way you can do it, but this is the way that I've found that works so that we get all of them and we don't miss any of them. All right? So the first line segment that I see up here is this small one over here, KL. I'm going to start on the left-hand side and I'm going to work my way over. So KL, I'm going to write on the line. It gets a dash over the top with no arrows. This is the segment notation, no arrows over the top. So we could do KL or LK, but that would not be distinct. All right, so there's one of them. I start at K and I stopped at L. I could start at K and I could blow right past L and come all the way over to M. If I were to take my scissors and I were to cut here and here, the space in between would be my line segment KM. Do you guys see any other line segments that would still have K as the left endpoint? KN, yes. KN. All right. I've gone all the way from the left now to the farthest point on the right. So now I'm going to start back over at the beginning, but I'm not going to go as far left as I can go. I'm going to leave K out this time, and I'm going to start at L. I can go from L over to M. So segment LM. Do you see another line segment that would have L as the left-hand endpoint? LN, yes, LN. There is one last line segment up here that we have not named yet. We've done KL, KM, KN. We did LN and LN. MN, yes. So that's the way I make sure that I get all of the line segments. How many line segments total did we find? 6. 6 distinct or different line segments, yes. I start on the left and I move a little bit right, a little bit further right, a little bit further right until I go as far as I can to the right. And then I start back over at the left-hand side, but I pull in one. And then I go to the right, to the right, to the right, to the right until I can't go any further. Like I said, that's not the only right way to do it, but that's the methodical way that I have found so that I don't miss any. All right, let's look at number 2 down at the bottom of the page. Name 3 collinear points. There is one line up here that has 3 dots on it. What are those 3 dots? B, C, and A, or A, C, and B, yes. Beautiful. Name the plane 2 different ways. What do they mean by the plane in this particular picture? How are they representing that in this picture? Yeah, it's that red or pink splotch, right? What would be the easiest way to name this plane? Plane J. Would I be allowed to call this plane G? Why not? Because it's a point. We can call it plane J because it's an uppercase letter with no dot next to it. If it has a dot next to it, I need how many to name the plane? If there's dots next to them, I need how many letters? 3. Can those 3 letters be in a line together? No. I have to be able to draw what shape? Have to be able to draw a triangle. Give me another name for this plane. Plane CDE. A. I like it. Plane C, D, A. I can draw a triangle between C, D, and A. Can somebody give me another name? I know they only asked for 2, but can you give me a different name? CD what? CDB. Plane CDB. Let's see if we can go for one more. BDG. Plane BDG. Nice work. We'll go ahead and stop with 4. That's way more than they asked us for. Name 2 points non-coplanar with A. E and F. Point E is above, point F is below. So it's kind of like if I have my folder like this, E is over here, F is down here somewhere. Name a line that contains point A. What did we say? H. We can call it line H. Can you give me a different name for that same line? AC. We could call that line AC, but now I have to remember to do the dash with the arrows over the top. If we call this line H, we have to write the word line out. Could I call that line AB? Yes. Could I call it line BC? Yes. Give another name for line I. DC. Or could we call it CD? Yes. I'm always allowed to flip the letters around. Name a line segment on line H. I want just a segment on this line. AC or BA. Let me write both of those down. AC, BA. So I only see one other line segment on there. Can you guys find the last line segment on H? CB. Very nicely done. Let's go ahead and flip over to page 6. We're going to talk a little bit more about line segments. The very first thing I want to do is write down our line segment notation. So if I have AB with a dash and no arrows over the top, I'm going to add this to the margin. I would like you guys to add this in the margin. Or BA with a dash over the top. These are not distinct. And the dash over the top is my segment notation. So if I want to talk about the whole line, I put a dash with arrows over the top. If I want to talk about just a piece of a line, I put a dash with no arrows over the top. I cannot measure a line because the arrows on the line mean that it never stops and it never starts. It goes on forever and ever in both directions. So I can't measure a line. But as soon as I take out some scissors and I cut through that line, and now I have ends to it, I have a beginning and an end, now I can measure that segment. We name our segment based on where we start and stop, the end points. And once we start introducing this idea of line segments, pieces of lines, then we introduce a concept called the betweenness of points, although I will probably never refer to it that way again. On this line right down here, I want you to write what we're going to refer to it as, which is the segment addition postulate. The segment addition postulate. And then right here in this box, we're going to draw a line segment here. And we're going to put some points on this line segment. So I'm going to call this point A. I'm going to call this point C. And down here, I'm going to call this point B. The segment addition postulate says if I have 3 points that are all on the same line together, I take my big line segment, this one right here, and I can break it into 2 smaller pieces, 2 segments that are side by side. They're joined in the middle there by point C. They touch each other at point C, but they're all in a big long line together. If I have a situation like that, and I know that from A to C is 2 inches, and I know that from C over to B is 5 inches, then I can take the length from A to C, 2 inches. I can add it together to the length from C to B, which was 5 inches. And that gives me the length of the bigger, longer line segment. How far would it be from A all the way over to B? 7 inches. Perfect. Now, before we go and try some practice with this, I want you guys to notice something about this. Down here, where it says AC plus CB equals AB, do you notice how there's nothing over the top of those letters? There's no line with arrows. There's no dash over the top. When there's nothing over the top like this, it means length or distance. So it has a meaning if it has a dash with arrows. It has a different meaning if it has just a dash. And we have a third meaning if there's nothing over the top of it. If you see nothing over the top of 2 letters, we're probably going to replace that with a number. If it has nothing over the top of the 2 letters, we're probably going to replace that with a number. All right, let's try some examples. Find measurements by adding. So what we want to do is we want to find from here all the way over to here. How big is that? Oh, yes, I am sorry. Absolutely. Oh, and then nothing shows up on the screen. You got it? Okay. Okay. So on my line segment that it's showing, from X over to Y is 11.3 centimeters. So that's the first thing I'm going to write down. I'm going to write down X, Y, plus, and then right underneath that, I'm going to write 11.3 centimeters plus. I'm replacing the XY with 11.3. This is the line segment right next to it, YZ. How big is segment YZ? 3.8 centimeters. And those 2 smaller segments together make XZ. Well, what do I get if I add 11.3 and 3.8? 15.1 centimeters. So XZ equals 15.1 centimeters. All right. Let's do part B. What are the two smaller line segments that we have here? DE is one of them, so I have DE plus, what's the one right next to DE? EF. So DE plus EF equals, what's the big long one that I get when I take DE and put it together with EF? DF, yes. So DE plus EF equals DF. DE says it is 2 7/10 inches. Who likes working with fractions? Yeah, me either. How do you guys feel about changing these into decimals? Does that sound better? Thank you. What is the denominator on this fraction? 10. That actually makes it super easy to change into decimal form. 7/10 is 0.7. So this is 2.7 inches. So that's what I'm going to replace DE with, is 2.7 inches. Plus, segment EF would be what in decimal form? 5.9. 5.9 inches. All right, let's take those and add them together to figure out how big DF would be. 8.6, yes. 8.6 inches. So DF equals 8.6 inches. Beautiful. Do you guys know how to take something that's in fraction form and change it into decimal form using your calculators? What button do you use on the calculator when you see a fraction bar? This guy? You can use that. That'll change it into a decimal if it's already in your calculator as a fraction. What about if you don't have a button like this or a button like this on the calculator? What other button can you use when you see a fraction? Division. So you can change it into its decimal form on this one by doing 7 divided by 10 and then writing down that decimal after the whole number. Let's look at the next problem where I'm actually going to ask you to do that. This time, I know how big the long segment is. And I know how big one of the small segments is. I want to know how big this other small segment is. So what are the two small segments that we're going to put together for the big one? What are the names of the two small segments? PQ and QR. So PQ plus QR equals, what's the name of the big segment? PR. PR. Segment PQ is 6 5/8 inches. Can somebody do 5 divided by 8 on your cell phone calculator for me? 0.625. So this would be 6.625 feet. So 6.625 plus, I'm going to leave this QR since we don't know how big it is, equals, what is 3/4 in decimal form? Yep, so 13.75. So I have 13.75. What can I do to this if I want to get QR all by itself? Subtract. So we're going to minus 6.625 from both sides. And that means that QR is how big? 7.125 feet. Yes. All right, let's do the last section of this question, and then we will call it a day. So I want to write out in symbols first. So I would have PQ plus what? QR equals PR. Yes. What can I put in for PQ? PQ. I don't know what it is, so I'm going to leave it as PQ. plus, what goes in for QR? 17.8 equals what? 24.3. So how do we get PQ by itself now? Yes, we're going to subtract 17.8 on each side. And that means that PQ is what? 6.5. Do we need units with that? Centimeters. Beautiful. Absolutely fantastic work. Out of 12 years of doing this now, you guys caught on to that faster than any other class I've ever had. Fantastic work. Don't forget, homework number 1 is due tomorrow. And then we will keep talking about segments tomorrow.